Let's take a look at how the human immune system is designed and what happens to the system in Sjogren's disease. Imagine your body as a bustling city. Every day, invaders like viruses, germs, bacteria, and other threats try to sneak in. Luckily, your body, or city, has its own security force, the immune system. The innate immune system, one of two immune responses, is the fast-acting street patrol. They fight in broad ways, not caring who the enemy is, just that something unknown is on your turf. The innate immune system is made up of responders who look for intruders and attack them directly, or support other parts of your immune system to fight them off. Macrophages are like garbage trucks. They swallow invaders and clean up debris. They even post wanted posters by showing parts of the germs to other immune cells. Neutrophils are like emergency firefighters that help to break down invaders so immune cells can clear them away. Other responders are called natural killer cells. They're like secret agents who patrol for cells that have been hijacked by viruses or turned cancerous and quietly remove them. Then we have the dendritic cells. These cells act as neighborhood watch reporters. They snap Polaroids of invaders and run them back to headquarters, the lymph node, where the adaptive immune system takes over. The adaptive immune system response is slower at first, but much more precise and strategic. This system is made up of B cells, plasma cells, helper T cells, cytotoxic T cells, and memory T and B cells. B cells are archers. They prepare and design the arrows, or antibodies, but they do not actually release them until they are promoted. An antibody is like the archer's handcrafted arrow, but the tip only clings to one specific target. Once released, these arrows mark the invader, so the rest of the immune system knows exactly where to strike. Plasma cells are grown-up B cells that can actually fire the arrows. Helper T cells are police chiefs with megaphones, orchestrating the immune system response. Cytotoxic T cells are special forces teams, knocking on doors and neutralizing traitor cells with precision. Memory T and B cells are detectives with photographic memory, keeping mugshots on file for future encounters. So, what's happening in your body when you have Sjogren's disease? In the moisture-producing gland neighborhoods of our city, the epithelial cells, the protective walls of the glands, can sometimes behave in unusual ways. Some people are born with the potential for small cracks in their city walls. On their own, these don't cause problems, but later, outside triggers like viruses, chemicals, or even factors in our environment or food can stress the walls and set off alarms. Scientists are still studying these triggers, and no single cause has been proven. The epithelial cells then overreact, calling in more immune cells and worsening the damage. They call in dendritic cells, the neighborhood watch reporters, who can also release interferon alpha, which can fuel the inflammatory response. This sparks a cascade. Natural killer cells arrive, T helper cells orchestrate and sustain the attack, and B cells are pushed to multiply, driven by powerful immune messengers called cytokines, like BAFF and interferon. One reason this happens is because of BAFF, short for B cell activating factor. BAFF is like an overzealous coach, keeping B cells alive and multiplying, even when they shouldn't. That creates too many antibodies, including autoantibodies that attack the body's own systems, tissues, and organs. Doctors detect autoantibodies in blood tests. While not every patient will test positive, they are an important clue that helps confirm a diagnosis of Sjogren's disease. At first, the damage caused by autoantibodies is like temporary street closures. But if the response continues, the city suffers irreversible destruction. This leads to Sjogren's disease and its symptoms of fatigue, brain fog, dry eyes, dry mouth, systemic complications like joint, lung, and nerve issues, and other problems. Sjogren's can affect the entire body. Scientists are still uncovering why autoimmune disease, like Sjogren's, looks so different from person to person. That's why research is critical. It moves us closer to therapies that address Sjogren's disease and improve life for those living with it. To learn more about Sjogren's, visit sjogrens.org.